Can time really freeze? Welcome to Split Screen. I'm your Professor Pilot. Today, we are exploring one of the most fascinating questions in physics. Can time really freeze? Imagine this. You are standing in the middle of a busy city. Cars are speeding past you. People are walking. Birds are flying overhead. And suddenly, everything stops. A car frozen, mid-motion. A glass shattering in the air. Suspended. A bird's wings. Locked in place. The world is completely still. Not slowed. Not paused for you. But completely frozen. Is this just science fiction? Or could it actually happen? Let's investigate. Before asking whether time can freeze, we need to understand what time actually is. Most people think of time as seconds, minutes, and hours, something measured by clocks. But in physics, time is not just numbers on a clock. Time is a dimension, like length, width, and height. It is part of something deeper called space-time. More importantly, time is connected to change. If nothing changes, no motion, no transformation, then time has no meaning. Time measures change. No change, no measurable time. If time were to freeze completely, all change would have to stop. And that has enormous consequences. Modern physics tells us something extraordinary. Time is not constant. It can slow down. This effect is called time dilation. The faster you move, the slower time passes for you. Imagine two identical twins. One stays on Earth. The other travels close to the speed of light and returns. Less time passes for the traveler. They return younger. As speed increases, time slows down. At the speed of light, theoretically, time would stop. But objects with mass cannot reach that speed. It would require infinite energy. So time can slow dramatically, but it cannot completely freeze due to speed alone. Speed is not the only factor. Gravity changes time too. Massive objects bend space-time. The stronger the gravity, the slower time passes. Consider a black hole. As someone approaches the event horizon, their movement appears slower and slower. To a distant observer, they look almost frozen in time. But from their own perspective, time feels normal. They continue falling inward. So does time freeze at a black hole? Not exactly. It only appears frozen to an outside observer. Now something even more fascinating. Light travels at the speed of light. At that speed, according to relativity, time does not pass. From the perspective of a photon, a journey across billions of years is instantaneous. It sounds like time freezing. But this does not mean time freezes for the universe itself. It only applies under extreme theoretical conditions. Now we can answer the question clearly. Can time slow down? Yes. Speed slows time. Gravity slows time. Can time almost stop under extreme conditions? Theoretically, yes. But can time completely freeze for the entire universe? No. Time is linked to motion and energy. If time stopped everywhere, atoms would stop vibrating. Electrons would stop moving. Light would stop traveling. No processes would occur. And without processes, nothing exists in a meaningful way. A frozen universe is not a paused movie. It is the absence of change. Without change, physics cannot operate. Science allows time to bend, but not to break. If you enjoyed this video, like and subscribe. This video is created purely for educational and informational purposes, based on current research and publicly available information. Viewers are encouraged to do their own research.